This is a top-down 2D space shooter built in Unity. The game uses a bootstrap scene to initialize all persistent managers, then loads the main menu, and from there, the game scene. I'll walk through the key architecture and design patterns used. Each manager registers itself here when it starts up, and any other script can request it by its interface type. So, for example, the application manager registers itself, and when the UI needs it, it just calls getService. The save system uses a backend abstraction pattern. IDA.backend defines the contract save score, getLeaderboard save player data. There are two implementations: local JSON backend, which saves to a JSON file in persistent data, and playFOC backend for online leaderboards. The database manager picks the right backend at runtime. Currently, I am using local JSON. The player has two attack types, both data-driven via weapon data, scriptable objects. Left click fires rapid bullets, low damage, but fast fire rates. And they can destroy enemy projectiles, which adds a defensive skill element. Right click fires a missile. It deals area damage on impact and is much stronger. But missiles are limited ammo. You start with a set amount and need to collect missile pickups from enemy drops to replenish. There's also a cooldown timer between missile shots, shown by a reload slider in the HUD. This creates a strategic choice: spam bullets for safety, or save missiles for tougher enemies. Enemies use the abstract factory pattern. Enemy factory is an abstract mono behavior with create melee enemy and create ranged enemy. Concrete enemy factory implements it, using the object pool to recycle enemy game objects, instead of constantly instantiating and destroying them. Adding a new enemy type is simple. Create a new enemy data, scriptable object. Set its stats. Create a prefab with enemy base or a subclass, and add it to the spawner. No code changes needed. When enemies die, they use a weighted random loot drop system. Each enemy data scriptable object has a list of drop configurations, each with a pref and a drop weight. There's also an overall no-drop chance, so enemies can sometimes drop nothing. The system calculates total weight, picks a random number, and walks through the list to select a drop. Players collect coins and items to progress. The difficulty manager makes the game progressively harder as you play. It works in two ways. First, every few kills, all enemies get a small stat boost. They hit harder, take more damage to kill, and move a bit faster. Second, at certain kill milestones, new and tougher enemy types get unlocked and start appearing in the game. Game state is managed through the application manager, which implements iApplication Manager via service locator. It uses a game state enum default main menu. Gameplay paused, game over, loading. The set game state method switches state and controls timescale. For example, pausing sets timescale to 0, gameplay sets it to 1. Other systems check current game state to decide behavior. Enemies only spawn during gameplay. UI shows different panels per state. The world uses chunk-based procedural generation. World Manager is a singleton that tracks the player's current chunk coordinates. Every frame it checks if the player moved to a new chunk, and if so, generates new chunks within the view distance radius, and unloads distant ones. Each chunk prefab has a map component that generates its tile content procedurally. This means the world is effectively infinite. You can fly in any direction, and new terrain generates around you.